Good morning. As we have seen yesterday, the timber is subjected to natural insects attack, such as beetle, termite, woodpecker, marine insects. So one defect is it is susceptible to natural insects. Then for natural forces, the timber will be subjected to not KNOT, not. Then for fungal attack, timber will be subjected to fungal attack such as rots, dry rot, wet rot, white rot, brown rot. Then because of season, when timber seasoning means cutting the timber to the required size, keeping for alternative weather, drying and wetting. This process of alternative drying and wetting may result in warping. Warping, sometimes it may become cup or bow. Sometimes it will bow means it becomes convex. Cupping means it will become concave. Knots means you will have a projection, unwanted projection on the bark of the timber. In the tree itself, you can see a branch will not come out of it, but you can very well see, you have seen, especially in mango trees. In mango trees, weaker trees will be subjected to this attack more than stronger trees. It will be very difficult to attack teak wood and rosewood, even jackwood, because they are structural timbers. So they have more resistance. Trees which are not that much resistive against these elements such as insects, natural forces, fungal attack, seasoning. These are the defects. In brief, we have to safeguard the timber wealth of the country as we have to safeguard the natural fire resources. Timber includes in that. So in construction industry, the traditional timber is gradually giving way to man-made components for doors, door frames, window frames and ventilator frames. And even furnitures also to a great extent has given way to synthetic materials. So we complete another building material, timber. Coming to the next timber, our next building material is steel. Steel, whenever the timber is giving way to a new material, steel occupies that place first. You have steel door frames, steel window frames, steel handrails, steel parapets, steel jolly works, steel handrails. You have even stainless steel. You have, according to the, it will be coated, oxidized steel. You have mild steel. You have galvanized iron, GI. You have tar steel, deformed steel. Deformed steel or tar steel is used for reinforcement. They are rebars, reinforcement as reinforcement bars, tar steel. Initially, it was mild steel. Now, mild steel is totally without these deformations. You will not have any outer windings. It is not deformed. Plain steel, mild steel. According to the carbon content, steel is categorized. So mild steel, low carbon steel, tar steel, deformed bars. Then as you have stainless steel. Stainless steel is used for handrails, parapet protections, jolly works, decorative works. Then there are steel sections, as we have seen in railway engineering, I sections, solid I sections. Very common, symmetrical I section and non-symmetrical I sections. Then angular section, L sections. Because of the development in steel construction, these angular sections are given way, is giving way. Angular sections are not common. Was giving way to tubular sections. GI as well as mild steel. Tubular sections, angular sections. Now the latest is the box structure. You have just like a trough, box structure. So angular, you have different sections. If you see the handbook on steel, IS 800 and handbook on steel, you have various angular sections, I sections, all sections of steel. For the box, a separate code is there. In handbook, whether in the latest revision, whether the box is included or not, I'm not sure. But anyway, there is a separate codal provision. If usually these steel sections are used for fabricating trusses, steel truss. Yesterday we told that the king post truss and the queen post truss can accommodate only lesser spans. When the spans are more high, you cannot go for timber trusses. At that time, you go for steel trusses. For any span, you can go for steel trusses. Initially, steel trusses were made of angular sections. You have equal angles and unequal angles. Then tubular trusses. Now you have the box trusses. Box type. Box has completely dominated, used for steel trusses. Steel can be used as a beam. Steel can be used as a column. Steel can be used as a plate. Steel can be used as a girder for any span. Steel is highly strong in compression and tension. That's another advantage. It is versatile in taking up tensile load as well as compressive load. Steel is the third stage according to the carbon content. It's around iron. Major is Fe, iron. You have cast iron, wrought iron, and steel. That's it. Cast iron has its application in certain field of foundries, lakes, boilers, sometimes on their bases. Cast iron will have their applications. Smithy, wrought iron, and the carbon content is little more, then it becomes wrought iron. Then you have the steel, low carbon steel, high carbon steel. Steel whole structure is steel. World Trade Center. All of us remember with respect the World Trade Center made totally of steel. The twin towers were of steel. And most of the modern civil engineering structures are basically steel structures. As we have seen, the advantage of steel is that it is highly resistant against compression and tension. It is vibration resistant. It can take heavy shocks, okay, because its ductility is more. So it can stand vibrations. So it can take impact loads. Steel can take impact loads. And the overall dead load of the structure will be less if you rely on steel frameworks. The load transfer is to steel frameworks. The total dead load, because all civil engineering structures, the major disadvantage of civil engineering structures is its dead load. As in the case of human body, whenever your weight, fat, it's known as the self weight. In civil engineering terminology, the dead load is called the self weight of the components of the structure. Self weight of the dead load is more than the live load, always in all structures. So one method of making the structure of the building more efficient is reducing the self weight or dead load. That's a principle. So lightweight structures are preferred to heavyweight structures. The one advantage of lightweight structure is that it will be highly resilient, shock resistant, wind resistant, and also earthquake resistant, because the mass is the reason for the impact of earthquake acceleration. So if mass is less, the effect of earthquake on the structure will be less. That is another advantage of steel structures. And you can have steel structures of any form. 3 connections were there initially, such as riveted connections. The steel elements will be connected using rivets. Then it has given the way to weld connections. Arc welding, gas welding, different types of welding. They connected. Now you have the welded connections. Most of the steel works are done connected together using efficient welding systems. In between rivet and weld, I again remember to tell, is the bolt, nut and bolts. So rivet, then rivet gave way to bolt, then bolt and nut gave way to weld. In the fish plate, you have seen line to rail lines. The fish plates, you will have holes drilled on the body of the rail and the fish plates. Then they are tightened using heavy bolts. So riveting, then bolt and nut, than the weld. Electric welding, electric arc welding, gas welding. So we'll continue tomorrow. Thank you. God bless.